The Chief Marketing Officer of Active Endpoints, and I'm joined today by Michael Rowley, our Chief Technology Officer. Welcome, Michael.
Thank you.
Our topic today is single sign-on for accessing task lists. Before we get started, what I'd like to do is just point out that a good user experience on the first bullet will be to simply hit the icon circled in red there so you can see a full screen. At the end of Michael's presentation, we will, and we encourage you to give us questions, and you can see the questions box there. Just type them in, and we'll take them one at a time. The intent of CTO Tuesdays is, well, we run these every week at the same time, noon Eastern Standard Time. They're intended to pick a particular topic that we think you'd be very interested in. It's really for the development team specifically. Roles would be enterprise and application architects, project managers and developers, as well as those of you that might be evaluating BPM or the related technologies and just want to learn more from Michael. We also have these recorded and others archived on our website, so we encourage you to take a look at previous topics that you might be interested beyond this one. With that, I'll turn it over to Michael.
Thanks, John. Let me grab control of the meeting. Here we go. So I'm going to be talking about single sign-on for accessing task lists. You may have heard of single sign-on and you're basically familiar with it. Let me just describe first why this fits as a BPMS-related topic before I go into the meat of it. A BPMS naturally provides many benefits. Easy creation of processes, so easy to share process models with other stakeholders so they can understand what's happening or what will happen, easy to see what's going on at runtime, modify it potentially in like a console environment. But one of the key values is an end-user facing application for starting processes, accessing task lists, individual tasks, reports, etc. In ActiveVOS, that application is ActiveVOS Central. Although developers can create their own end-user environment just using APIs like the standard API called the WS Human Task API. So it is as or more important for this application, this task list application, to work with single sign-on frameworks as any other enterprise application. Because of the fact that when you go and work on tasks, you're often in an environment where you're wanting to switch between other enterprise applications, and so you're frequently flipping between essentially the application that is the work list and some other application. So in the agenda for this is I'm going to give a kind of probably overly simplified explanation of encryption and authentication technologies that are used by single sign-on, then a description of single sign-on itself and its benefits, a description of kind of what goes on under the covers for, or otherwise known as a choreography of messages used by single sign-on, and then finally, single sign-on for task lists and ActiveVOS Central in particular at the end. Regarding the explanation of encryption and authentication technologies, there are several things where I think I can claim expertise. This isn't really one of them. But I find that there seems to be a divide between people who are security experts and encryption experts and kind of everybody else. And the security and encryption experts tend to use language and talk about certificates and and confidentiality and a bunch of, they throw around terms and throw around trust scenarios in a way that assumes that you know it, and so many people don't know it at all. And I would like there to be more people in the middle, of a basic understanding of what's going on, and yet aren't themselves experts, because I think it's valuable. So let's first go into encryption. Oh, actually, before we go into encryption, I want to talk about some of the glossary. There's a bunch of glossary or terms that people tend to bounce around, but these are things that people sometimes get confused about what's meant. Like authentication and authorization sometimes get mixed up as to which one is meant, and people use one term for the other. Authentication is the process of finding out who someone is and making sure they aren't lying. So that's all it is. It doesn't say what they can do. It's something else. It's authorization that says whether they have permission to do something. And authorization isn't itself authentication. It depends on dealing with already knowing who the principal is, who the person is that the question is about. And then finally, the word credentials is bandied about a lot, and that is merely something used to identify someone. So it is typically either something they know, such as a username and password, something they have, such as a little hardware token that generates little random numbers every few seconds, or something they are, and that's where biometric fingerprints and retinal scans and that sort of thing come in. The most common, obviously, is username and password, so oftentimes credentials and username and password are used interchangeably. So let's look at public key cryptography to go to the basic underpinning of this whole thing. The basic technology, the basic insight is that there's a lot of value in having asymmetric encryption. So you need to be able to encrypt messages and decrypt messages, but you want to have it, there's value in having it so that there's one key, and by key I just mean a number, usually a very long number, one key for encrypting a message and another key for decrypting a message. And with these two separate numbers, encrypting and decrypting, there's a number of use cases that come out. The theory behind this is that it's all based on a basic concept, which is that encryption should be easy and decryption without a key should be hard. Some math operations are easy to do one way, but hard to do in reverse. So think about, pairing these things up. In fact, way back in 1874, a guy named William Jevons noticed that multiplying and dividing large numbers is easy, but factoring large numbers is hard because you essentially have to try all the primes. There is no algorithm for just in like log n time, in a small amount of time, finding the factors of a very large number, like hundreds of digits kind of thing. And that this asymmetry in what's hard, multiplying, dividing versus factoring, can be used for encryption. He didn't actually figure out a mechanism for it. That didn't happen until a century later. The RSA algorithm was devised in 1978. That's the best known one, published from these three guys at MIT. It happens that 5 years earlier, the UK intelligence had come up with almost the identical mechanism, but they weren't kind enough to publish it to the world. It is, I think, interesting that this did make it out as a public concept. That it used to be that the way you dealt with secrets and encryption was the mechanism for keeping the secret, for encoding or decoding, was super secret. The whole mechanism can be known. And the only thing that's secret is the key. And that's something that security experts really like, which is that you not depend on a large number of things being secret. That the software doesn't have to be secret, the approach doesn't have, all of these things don't have to be secret. You can hang all of your secrecy in one big number and the mathematical properties of that thing. And that's, I guess we're kind of used to it now, but it was a big insight at the time. So there are several use cases for this. One is sending a private message to someone. In this scenario, the encryption key is made public. Anybody in the world who wants to send a message to this person can find that person's public key, encode a message to them. Nobody else can read it, including the guy who wrote it. Can't read it again, except for the fact that he knew what he encrypted. And then the only person who can read it is the guy with the other key, which is private, and that's the recipient. Now that's just for a one-way message. If you want to go with two-way, then you can just share them. Each person have a key, public and private key, and share back and forth. And that actually is the way transport level security, what used to be called SSL, is used. Each side, and by the way, transport level security is what's behind HTTPS. Whenever you go to a website that starts with HTTPS, it's based on this technology. And each side is generating has both a public and a private key. They exchange their public keys and they send private messages back and forth. So now, different from protecting people from reading messages is protecting people from writing messages or modifying messages. And that's a completely different use case for public key cryptography. A digital signature is used to protect against unauthorized changes to documents. Security people call this message integrity. What happens is the encryption key is private, which is the exact opposite of what we talked about before for sending messages. In this case, the encryption key is private. The guy who signed the message has a private key. As part of signing, what you do is you run a hash, what's called hash code of the message. You look at all of the contents of the message, do something like sum it up or whatever it is, and take it a module of some number, so that you have a little, a fairly short, many bytes, but much smaller than the original document, representation of the document. Anybody can generate this hash from the document. And then you take that hash and you encrypt it with the private key, the guy who authored it. Now, if somebody else comes along and, well, let me go on to the decryption, the guy who wants to verify that the signature is right. So in this case, the decryption key is public. So anybody can look at a document and know whether it was really authored by the guy who claims to have authored it. They just take that guy's public key, decrypt the hash, run the hash algorithm over the message, and see if it generates the same hash as was in the decrypted hash. And then they know it matched. So if somebody else comes in and modifies it, they can modify it, and they can send it to you, but its hash code won't line up. And they can't generate a hash code that would line up. And so that allows you to protect against people making these kind of changes. So another one is digital certificates. This is still in line with how do you use this public key cryptography. And this is oriented around the bootstrapping problem. So in both of those scenarios, both signatures and private communication, I said, get the other guy's public key. Well, that introduces a vulnerability. What if somebody claims they are Bill Gates and they give you a public key that corresponds to their private key, but they aren't Bill Gates, right? Now you take that thing and you send them a message and you sent it to the wrong person and they get to read it. So how do you know the public key you're going to encrypt something with or decrypt a signature is for the right person? And the answer is, see if someone you trust says that it's their public key. And the way that works is that the someone you trust is the certificate authority. So there tend not to be very many of these. So both parties are likely to find one that they both agree on is a valid certificate authority. Examples are like VeriSign, Entrust, DigiCert. And there are probably about a dozen, I would say, of these. And each certificate authority generates certificates. So this is when there's often discussion when you get into SSO and a lot of security things, there's always talk about certificates. So what's a certificate? A certificate is merely a document that says this public key is associated with this person, with this identity. And usually this person is represented by a domain name, right? So at ActiveVOS.com, what public key should I use for talking to ActiveVOS.com? Some certificate authority should be able to verify what public key I should use for talking to this company. And then, so that's a regular old XML document, easy to read. But how do you know that this certificate's valid? Well, now we're going to go back to the previous page, signatures. The document is signed by the certificate authority. So now we're starting to get to the root of this recursion, because now if you want to validate the certificate, you have the public key of the certificate authority, and then you use that to validate that the signature on your certificate is right, and then you use that to get at the public key of the guy you want to talk to. So it's this weird sort of recursive trust, right? But it depends on there being a root to the recursion, that there's some small number of certificate authorities, and then you sign information to get information about other people that you only sort of know. So now, tokens. Need to know about tokens in order to know about single sign-on. A token is a representation of an authenticated user that can be passed in a message. Now, I had talked about things like credentials can be things like a fingerprint scan. Obviously, the fingerprint scan itself is something that happens at one place in time. Eventually, it has to be turned into something that you can send as a message. So, and there's various things that can be passed around like this. So it's a serialized representation of credentials. The simplest is username and password, and you can send around username and password in clear text in the middle of a message that you send to somebody else, which is generally a bad idea if you're sending it over an unsecured channel. Somebody can read it, they end up seeing the password. It's not even a good idea, even if it is a secure channel, because the guy you're sending it to can read it. And you often don't want the person you're sending it to, you don't want the password getting around a lot. So, and I'll get into that more in a bit. An alternative is a standard called SAML, which has SAML tokens. SAML stands for Security Assertion Markup Language. It was first standardized in 2002 by Oasis. And it is, to quote Oasis, an XML framework for exchanging authentication and authorization information. So a SAML token is merely a little document that says something about someone. You know, it says that if it's in a message, it says the message I'm in was authored by or is associated with a particular person. It can also say, and they're a member of this group, or and they're authorized to do something in your system. Or there's just, the reason why it's called an assertion markup language is that you can assert anything you want about the person you're talking about. And then some authority signs it saying, and I say this is true, right? And it's used by most single sign-on frameworks because there's somebody, whoever's doing the single sign-on, in charge of single sign-on is who's saying, and I say that this is sent by such and such a person, or this session is really the logged in by this user. So now, finally, Ladalita, we get to actual single sign-on. So in this, applications depend on an external SSO server to authenticate, we've already talked about that word, authenticate who they're talking to. The user logs into the SSO server before using any of their applications, or the user uses some application and it says, wait, they're not logged in, and it tells the SSO server to get their login. So you're only ever logging in to the single sign-on server. A trusted link exists between each application and the single sign-on server, so they can give information back and forth. And of course, the applications have to make sure that who they're talking to is really the single sign-on server. So there's a bit of validating of certificates that goes on back and forth to make sure that you're really talking to the single sign-on server. And when a new application is used in a user session, what the application does, instead of going and asking the person for the password directly, the application asks the single sign-on server for a token. So I'm going to show a picture of the messages that go back and forth in the various parties in a minute. But first, before I do, I want to say the benefits of single sign-on. Now, the first one is obvious, but there's more than just the first one. The first one is that you only have to log in once, and when you're a user, to access multiple applications, and so that means there's less time and hassle. It's the one that as a user you go, ah, oh, thank goodness. But there's more than just the making your users happy. It also makes it more secure, because one of the ways it makes it more secure is that it avoids training people to be continually entering their password places. And if you're kind of into a mindless mode of continually having something pop in your face asking you for your password, then you're more vulnerable to phishing, where something pretends it's one of the real applications and just asks you for your password, and now you're toast. So other advantages. For the organization itself, it allows them to centralize user credential management rather than having a bunch of different user repositories. This really decreases costs because there's, according to Forrester research, password problems and password resets generally constitute between 25% and 40% of all help desk requests. This is big, right? This is a lot of money. So if you can get it so that there are fewer passwords, there's less likely they're going to have to ask you for help, and in general, because they can keep track of it, and there's just fewer systems where they might need to have help. And to the first of those 2 points, it reduces password fatigue on the part of the user, which is a phrase meaning as people have to come up with more and more usernames and passwords for more and more places, they become less and less secure because they can't keep track of it all. So, and then finally, it helps safeguard the user credentials by allowing applications to know they're dealing with the right person, to authenticate users without having to access their passwords. This is the basic principle that the more people, or in this case applications, that know a secret, the less secret it is. There's just, you know, if you got passwords running around a lot, somebody's going to end up giving it away. So how does this SSO work? There's typically an SSO server and an SSO client. The SSO server is configured to access, is the only thing configured to access the identity store where the credentials are. It has a service, like a web service or a service interface to generate tokens and validate tokens. The tokens might be passed as cookies, HTTP headers, in request parameters. It doesn't really matter how they're put. As I've discussed before, the way you validate them is with the signature that's in them. So they can be sent in clear text. SSO servers are, of the ones out there, they're typically deployed as a web application to some application server, but it could be built on its own. And it provides the user's login and logout pages. There's also an SSO client. Now, that's the direct client of the SSO server. It's not the actual application. It's something that sits in between. It intercepts requests for protected resources, and it's what goes off and asks the SSO server for requests and to verify tokens and to identify authenticated users. And it's typically installed as a servlet filter. So some typical SSO providers, there's a couple of open source providers, CAS and OpenSSO, and there's a number of commercial SSO providers, and there's also in the main application servers, WebLogic, WebSphere, JBoss, they all have their own single sign-on framework that you can take advantage of. So so I started talking a little bit about the server, the client, which is here listed as the SSO filter / agent. Then there's the actual application, in this case the work list web application, and then the guy using the browser, the actual, Firefox or whatever it is. So it starts with an initial request to do something in an app. That gets intercepted by the SSO filter to verify the token. There's no token, or it's not valid. So it says, wait, he hasn't logged in yet. Redirect to login. So the SSO server says, show a login page. The user logs into the SSO server, which authenticates that they did it right, and then redirects back to the SSO with the token. That token is verified. They need to verify that it's a valid token. The SSO server validates it. The session's updated for that token, and then the work list application is finally asked for the request, whatever it is. Show me my work list. So that's the basic interaction. SSO is supported in ActiveVOS, our work list application, by some key features. It's always been possible to do SSO, but it required more coding and work on the part of people installing. Now it's easier because there's a separation of the container authorization from the user's authentic authorization. So in other words, when the WSHT talks to the ActiveVOS server, it can say, I'm the human task application, right? So it identifies itself as an application, not as the user. And then it can offload the handling of the identifying of the user to somebody else. And it can be used with generally any SSO provider. And the way you customize, you work with a new SSO provider is just some customization of the application descriptors that are specific to that provider, and they all have that little description. So to see again, and this time I didn't animate it, without single sign-on, there's this ActiveVOS Central that captures the password. This is this middle step, and goes and passes along the password to the underlying ActiveVOS server. So the password is being sent back and forth whenever there's interactions. With the single sign-on server, there's this new party. When there's a redirect to the single sign-on, I didn't show all the steps here, but it goes and validates that the right person, and with the login, then all that ActiveVOS Central knows is essentially the user ID, who I'm working on behalf of, and that is passed to the server in a special new header called run as, saying, I'm working on behalf of this person, and and I am ActiveVOS Central, so you can trust me. So it has a way of trusting some applications to merely make assertions about the identity of who's doing the work. And so another kind of summary of who's keeping track of what. The single sign-on server has the private key for SSL server identity. This has private keys with certs that map to, let's say, I'm ActiveVOS Central, that's the AD trust role. And then ActiveVOS server has the private key entry for its SSL identity. So that's a basic intro to what is single sign-on, what's the underlying technology, and what it's good for. John?
Thanks, Michael. At this point in our session, we're at the Q&A session, so if you can just take that questions box, we'd just begin to type in your questions, and we'd be happy to, Michael would be happy to take them. So first of all, though, to get the conversation going, let me pose a question. In terms of the presentation and single sign-on, if you've got a business process that's automated and you've got applications as well as systems being tied together, how does what does that mean in terms of these applications being used, multiple applications being used in a business process?
Okay, so if you're not, so I've primarily been talking about the work list application itself, which is probably the most frequently used application with your business process. But yes, the business process can also make use of other applications. That also can make use of single sign-on to do validation of the user. Tokens get passed around, and the standard is WS security. This is something that we've had for a long time. The standard is WS security for essentially passing around security authorization information, authentication information, who's requesting what, as in this kind of whole framework where there's multiple parties. So if you've got something that supports WS security, then that application can be part of a business process that doesn't require additional sign-ons.
Thank you. So at this point, we'd appreciate some questions from the audience. So please type your questions into the text box. Are there any questions that you might have? Okay, well, in the meantime, think about it for another second. That we do have, as I mentioned, here's a question. It says, can you use ActiveVOS 2.0 as SSO server?
I don't know. Like I mean, the specific list of SSO servers, as I said, generally they all follow the same approach, and any of them can be configured to work with our with ActiveVOS. But for any specific one, I don't have information.
Okay. Next question. Can you share SAML configuration used for ActiveVOS Central SSO?
Wait, the SAML configuration? Yeah, actually there's, well, I didn't want to get into it in this talk. When I put up the slides, I'll actually show some of the configuration that goes on with ActiveVOS for working with SSO, because that is some later slides in the talk that I didn't get to, but it seemed too detailed for this. So if you come back later and get the slides, you can see some of the configuration.
Or be happy to email us. You'll see Michael's email later on. The next question is, what level of latency do you have between Central and the server app?
Well, short answer again is I don't know, but generally for all of these frameworks, it's a very high performance interaction because it happens pretty frequently, and we haven't had an issue with when we do performance work, and we do performance work with a number of our customers. Single sign-on related issues don't tend to be where we have to concentrate. So maybe that's a good overview of it.
Thanks. Any other questions? Any other questions from the audience? As I mentioned before, please again type them into the questions box, but I'll also review the slide in front of you. We do run these webinars weekly. They are on the website. We'd appreciate any comments you have at the address, the email address there. You can download the replays at the address there. These we recommend that you go to our website to learn more about ActiveVOS. And if you have any questions, you see Michael's and my email addresses there in front of you. So no more questions from the audience. So thank you for your time, and hopefully we'll see you soon.